Hello and welcome to section 6.4. In this section, we are going to look at calculating probability and odds. To begin with, we're going to look at probability. Now, the probability is how likely something is to occur. So how we measure that is we measure that on a scale of 0 to 1. The closer something is to 0, the less likely it is to happen. And if you have a probability of 0, that means it's impossible. It flat out will not actually occur. If you have a probability of 1, then we know for 100% certainty that that event will occur. Okay, and the closer your number is to 1, the more likely it is to occur. If you have something around 0.5, okay, that tells you that it could or it couldn't happen. It's kind of like right there in the middle. So it's just as equally likely to happen as it is to not happen. So the equation that we're going to use to calculate probability, and I know we've seen this notation, we've kind of briefly talked about it in class, but it's P, and then we say it's P of the event that's going to happen. So in this case, it says it's the probability of the event is equal to the number of favorable outcomes divided by the total number of possible outcomes. And we'll do a few examples just so you can see how this works. But before we do any examples, we also need to understand what an outcome is. Now, an outcome is the possible results of an action. So if you kind of look at this little mini example here, when you roll a dice, okay, and we're just talking about your standard dice that you would get probably with any typical game, okay? A dice usually has the numbers 1, 2, 3, 4, 5, and 6 on it. So a possible result or a possible outcome for rolling a die would be that you could roll the number 4 or you could roll a number 1. These are what we call outcomes. If we flip a coin, like a standard quarter, penny, dime, nickel, something like that, you have two different outcomes. You can have either a heads come up or a tails come up. So each one of those results are what we call an outcome. And when you see the word event, an event is just any outcome or group of outcomes. So if I want to know the probability of flipping a heads, if I'm flipping a coin, the heads is going to be the event. What is the probability of that outcome? I'm going to have one heads out of two possible choices, which could have been either a heads or a tail. So if we look at example 1, it says find the probability for selecting the following using the word mathematics. Okay, so the first thing I'm going to do is I'm going to figure out how many letters there are in mathematics. So if we count, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 possible outcomes. So when I set my probability up, I know that 11 is going to have to be on the bottom because I have 11 different letters that are possible outcomes. Now, when I look at my first case here, this P of the letter A, so it looks like I have one letter A, two letter A's. So this is going to be 2 out of 11. So my probability of selecting a letter at random and having it be an A means I have two favorable outcomes or two possibilities out of the total number of outcomes, which would be the 11. If we look at the next example, it says the probability of pulling out the letter C. Well, when I look at this, there's only one letter C. So this probability is going to be 1 out of a total of 11 possibilities. Now, when I get to P of Z, okay, I look at the word mathematics and I do not have any letter Z's in the word mathematics. So I have 0 favorable outcomes out of 11 total possible. So if I simplify this, this is just a 0. And if you remember, a probability of 0 means the event absolutely positively will not occur. And by looking at this word here, you can see that there are 0 Z's. So I'll never be able to pull out the letter Z. For our next scenario, we want to find the probability of pulling out a consonant. Well, in this case, it's easier to figure out how many vowels I have. So I have 1 vowel, 2 vowel, 3, and 4. So the A, E, and I's are all vowels. So I have 4 vowels. I know I have 11 consonants. So that means I'm going to have 7 possible consonants out of the 11 total letters that are there. Likewise, when I get to this last one where it says the probability of calculating a vowel, well, we just found our vowels that there were 4 of them, so I have 4 favorable outcomes out of 11 total outcomes. And this is honestly all there is to calculating the probability. For example 2, we want to find the probability for spinning, and in this case it says we're going to find the probability of spinning an even number. So when we look at this, I see that we have 1, 2, 3, 4 even numbers. So this is going to give us 4 out of a total possible, and it looks like everything's numbered in order, so there's going to be a total of 8 outcomes. And if you wanted to, you could reduce this down to 1/2. So that means 1 out of every 2 possible outcomes is going to give me an even number. Now likewise, I can do the same thing if I want to look at what's my probability of spinning a 1 or a 3. Well, here's a 3, here's a 1, so that would be 2 out of the 8 possible outcomes, or 1 out of every 4 is going to produce either the number 1 or the number 3. And for my last part, part C, I want to find out what's the probability of spinning an 8. Well, you can see that I've only got one number 8 out of 8 total outcomes, so that would be 1/8. The last thing that I would like to cover with you is called a complement. Now the complement is actually the opposite of the event. So when you're calculating the probability of it raining, your complement would be the probability of it not raining. So it's literally the opposite. When you take the probability of your event happening and you add it to your complement, you should always get the number 1, because something happening and something not happening, if you add those together, that should give you 100% or that number 1. So when we look at our third and final example for the day, it says when you roll a number cube, what is the probability of not rolling a 2? So on a number cube, we have 1, 2, 3, 4, 5, 6. Now in this case, it's actually easier to calculate the complement, so I'm going to put the P of my complement, because it's easier, it's quicker. I see I have 1 number 2, so that's going to give me 1 out of my 6 possible outcomes. So to calculate the probability of not rolling a 2, I just have to take 6, subtract 1 from it, because I've only got 1 possible number 2, which is going to give me 5, and then I know I have 6 possible outcomes. So my probability of not rolling 2 is 5 out of 6, and the complement to that would be the 1/6 here. And if I add the 1/6 to the 5/6, that would give me 1, so that means I calculated it correctly. Now for part B, it says, what is the complement of an impossible event? So remember, an impossible event means that we have a complement of 0. So if 0 is impossible, and we know that the complement means that it's going to happen, this tells me that my complement must equal 1, because the opposite of something not happening would be that it is for certain going to happen. So the complement of an impossible event is 1. This is going to conclude part 1 for 6-4. If you have any questions, please let me know. Otherwise, have a great day.